I'm going to go over a couple problems from the Unit 2 Worksheet 1. We're going to start with number 2. Number 2, we're given a graph and we're asked to do a few things. First, A, state the open intervals on which f is increasing, and B, state the open intervals on which f is decreasing. To tell if a graph is increasing or decreasing, you trace it from left to right, and if it's moving down, it's decreasing. So we got decreasing here, I'm highlighting in green. And then notice tracing from left to right, it's increasing, so it's moving up all the way until it hits the peak there. And then back to green, because it's going to, once it hits that max, it's going to be decreasing all the way until that arrow means it keeps decreasing. So we see in green where it's decreasing, and we want to state open intervals. Open's the key word here, meaning we don't use brackets, always use parentheses, and when you use interval notation. And so our first open interval well, actually there's only one open interval for increasing, and you only use x values on these intervals. So we're looking at our starting x value at 1 and our ending x value at 3, so from 1 to 3. For the open intervals on which f is decreasing, the first one is looking at the x values -1, 2, 3, 4, 5, 6, and starting at -6, ending at 1. That's our first interval. The second interval starts at 3 and keeps going. That arrow means it keeps moving down and to the right, so to infinity. C asks us to state the domain and range of f. So the domain, we start at -6. This time we're going to use brackets because it's included with that closed circle. And then it just keeps moving to the right, so to infinity. The range, the lowest this graph goes, well, that arrow points down, so there is no bottom to the graph. And the highest it goes is the maximum, is where the vertex of that parabola is, which is 1, 2, 3, 4, 5, 6, 7. And it actually reaches 7, so we're going to use brackets at the 7. D says state the coordinates of any relative minimums. A minimum is where the graph changes from decreasing to increasing, or relative minimum. And so we see where it changes from green to yellow. I'll circle it. And so that's a relative minimum, and we want the coordinate of that point, so that's at 1, -1. So first green, then yellow, or first decreasing, then increasing. That's our only relative minimum. State the coordinates of any relative maximums. That's where it changes from increasing to decreasing. So using my highlights, where it changed from yellow to green, which would be the maximum, or the vertex up here, at 3, 7. And then F says write a two-pieced, piecewise defined function f that accurately represents the graph of f shown above. So for our first piece, the line, notice it's going through 0, 0, and so it is a type of parent graph. So it's in the form y equals some number times x. That number is a slope, and if you take a couple points, you could see down one, right one, so the slope would be negative 1 over 1 or negative 1. So y equals negative x is the graph of the highlighted one in yellow. It does have a restriction, but I'm going to come back to that restriction. The parabola comes from a quadratic equation in the form y equals ax squared. That would be the parent graph. That's when the vertex is at 0, 0, but the vertex has been translated to the right 1, 2, 3, and up 7. So we're going to rewrite that quadratic to reflect that translation, or represent that translation. So we have x minus 3 squared plus 7, and now we just need to find out what a is. A is not a slope. This is not created by a parabola is a curve, doesn't have a constant slope, but we pick a point that the parabola goes through, and I'll pick the point 1, negative 1. Plug in 1 for x and negative 1 in for y. And solve for a. I'm going to subtract 7 from both sides, then divide by 4, and we get a is negative 2. So our second function is y equals negative 2 times x minus 3 squared plus 7. And now we're going to create a piecewise function with these two pieces. So it would be f of x is equal to, our first piece is negative x, our second piece is negative 2 times x minus 3 squared plus 7. And these pieces happen over a certain domain. So it's going to be negative x if x is between negative 6 and 1. And it's going to be the quadratic if x is greater than or equal to 1. Number 4, we start with another graph here, and we're looking for open intervals on which f is increasing and then decreasing. When you're looking for increasing, you're reading it from left to right, and if it's rising, it's increasing. So there's a part that's increasing, here's another part that's increasing. And so those open intervals, just looking at the x value, the first one goes from 0 to 1. Keep them open, meaning use only parentheses. The second open interval goes from 2 to 3. For decreasing as you read it from left to right, it drops. And so there's only one spot where it's decreasing, and that happens from 1 to 2. X values only. Keep it at open interval using parentheses only. And then if it neither increases or decreases, we call it constant. So, and that goes from x equals 3 to x equals 5. D, state the domain and range. Domain, we're looking at all the x values, so the furthest to the left is x equals 0, and it's part of the graph. And the furthest to the right is x equals 5, part of the graph, and there's no gaps in between, so we just need one interval. For the range, the lowest is y equals 0. The highest is y equals 3. No gaps in between, the endpoints are included. E says state the coordinates of any relative minimums. A relative minimum is the point where it changes from decreasing to increasing. So in my picture where it changes from blue to green, we see a relative minimum at the point 2, 0. Notice that the point 0, 0 is not a relative minimum because it's not changing from decreasing to increasing. F, state the coordinates of any relative maximums of F. Relative maximum is a point where it changes from increasing to decreasing, so from green to blue in my picture. And that only happens at the point 1, 2. Again, the point 3, 3 is not a relative maximum, nor is 5, 3, because those are not points where it's changing from increasing to decreasing. Also be careful with notation, like the notation I use in B. 1 represents an x value, 2 also represents an x value. That represents the interval from 1 to 2, whereas in E, 2 represents an x value, 0 represents a y value, and that's an actual coordinate. It's a location of one point. And so we use a similar notation for two different things here, and so it's important to point that out so that you can distinguish between the two. For G, we're asked to write a three-pieced, piecewise defined function f that accurately represents the graph of f shown above. So our three pieces, we have you fit a parabola here in yellow that I'm highlighting yellow. We could fit a line segment there, or if you want, you could do part of the absolute value shape as well, and then again a constant line. So those are our three pieces. So we have f of x is equal, leave enough room for three pieces, so I'll work with the first piece first. It's a parabola, y equals something, x, that vertex is moved right to, right 1 up to, I got that wrong, right 1 up to, at the point 1, 2, and so it's x minus 1 squared plus 2, and it goes through the point 0, 0, so I'm going to plug in 0 for y and 0 for x and solve for a. And we end up with negative 2 as a. So negative 2 x minus 1 squared plus 2 if, or for, x between 0 and 2. The next, we're going to have a line. Notice the slope of this line is up 3, right 1, which is 3. And so it's going to be 3, and then I'll just pick one point, the 2, 0, which is translated right 2, so x minus 2, and that's our line if x is between 2 and 3. And lastly, we have the constant line y equals 3, and that's if x is between 3 and 5. Notice as well when we're writing these, I'm making, when two graphs share an endpoint, like my first graph or first piece, which is the parabola, ends at 2, and then the line starts up at 2. I make one have an open circle, one have a closed circle. you don't want them both to have a closed circle. They make a closed circle, but one has to be open, one has to be closed if they're connected. And that's it for that